Hello everyone, welcome to my channel. So in this tutorial we are going to discuss this C-DRX, that is connected mode DRX. Okay, but before going through this C-DRX, let's just go through what we have studied in last two lectures of DRX. Okay, so in lecture number 1 we have seen that if DRX is not configured in your network, in that case UE has to decode PDCCH in each and every subframe, which leads to heavy consumption of battery at UE side. Okay, so to avoid this thing, DRX is introduced. So in second lecture we have seen the I-DRX. Actually there are two types of I-DRX. Actually there are two types of DRX. One is C-DRX and another is I-DRX. So in I-DRX we have seen that parameters related to I-DRX are provided in SIB2. Okay, so parameters like paging occasion and paging frame are provided to UE. Okay, so with the help of paging occasion and paging frame, UE will wake up in a particular radio frame, and in that particular radio frame there will be a particular subframe in which UE is going to wake up. Okay, and UE will decode the PDCCH, and if some data is there it will receive that data, and for rest of the radio frame it will go back to in sleep mode. Okay, so means you have seen that how means UE doesn't have to decode PDCCH in each and every subframe, which will save its battery only if UE is in idle mode. Okay, so now we will see how the means in C-DRX this battery can be saved in RRC connected mode. Okay, so C-DRX actually it is of two types. One is, you can say, it's long DRX, and second one is short DRX. One important thing that I would like to tell you, that parameters related to both these types of DRX are provided to UE in RRC connection reconfiguration message. We will see what are those parameters. Okay, so first let's start with long DRX. Okay, so suppose UE is in RRC connected mode. Okay, so UE is in connected mode. Okay, the parameter of long DRX, let me write those parameters first. Okay, so first parameter is your long DRX cycle. Okay, this is the first parameter of long DRX cycle. Second parameter is on duration timer. And the third parameter is your DRX inactivity timer. DRX inactivity timer. Okay, so all these parameters are provided to UE using this RRC connection reconfiguration message. Actually, this message is used during initial attach procedure of UE. You can refer my initial attach of UE lectures that I have provided. Okay, so suppose long DRX cycle is set to 10 millisecond and on duration cycle is set to 2 millisecond, and DRX inactivity timer is set to 4 millisecond. Okay, so I'm going to draw the radio frame so that how these parameters works will be clear to you. Okay, so let's consider that UE is in RRC connected mode. Okay, because these long and short DRX will only work when UE is in your connected mode. So this is LTE radio frame. Okay, so 1 2 3 4 5 6 7 8 9 10. Okay, so this is one radio frame of Okay, so here you can see that long duration cycle is 10 millisecond. Okay, so 1 2 3 4 5 6 7 8 9 10. Okay, so this is one DRX cycle. Okay, or you can say long DRX cycle, long DRX cycle. Okay, so in that long duration cycle, on duration timer is of 2 millisecond. Okay, so my UE will be on in these two subframe. On means UE is going to decode PDCCH in these two subframes only. Decode PDCCH. Okay, if some data is there, then it will receive that data, and if there is no data, then it will go back to in sleep mode. So you can say this is sleep mode. Sleep mode for UE. Okay, now after that the other radio frame will be started. Okay, after this, so let me draw again those 10 subframes. 1 2 3 4 5 6 7 8 9 10. Okay, so these are next subframes. 1 2 3 4 5 6 7 8 9 and 10. Okay, so suppose now UE again decoded the PDCCH here. Okay, here. Okay, and it has found some downlink data here. Suppose after decoding PDCCH at this subframe, it has found some incoming data is there. Okay, just as I explained in last lecture, that UE may find out that PRNTI. Okay, PRNTI will tell that it's some paging is there in this subframe, some paging is coming, or it could be a CRNTI, some user plane data could be there. These are carried by PDCCH. Okay, for more detail refer my lectures on PDCCH RNTIs. Okay, one more thing, this is of 2 millisecond, this is 10 millisecond, this is the same 10 millisecond. Okay, this is on duration timer of 2 millisecond on this thing, on duration timer. Okay, this is only for 2 millisecond. Again, this will be a on duration timer of 2 millisecond, and this will be a long DRX cycle of 10 millisecond. These things, 10 millisecond, 2 millisecond. Okay, so now UE decoded the PDCCH here at first subframe in on duration timer. Okay, so suppose it has found that some data is there, some incoming data is coming here. Okay, so now whenever the UE find out, means after decoding PDCCH, whenever UE find out that some incoming data is there, just after that your DRX inactivity timer will be started. So DRX inactivity timer is of 4 millisecond, right? So for next 4 millisecond in this radio frame, third, fourth and fifth. Okay, so for these 4 millisecond, this is the same 4 millisecond DRX inactivity timer. UE is going to decode the PDCCH. Okay, means because some data will be received here. Okay, in first subframe, UE find out that the incoming data is there in first subframe. Okay, so it will receive data in suppose UE received data in second subframe, third subframe. Okay, and fourth subframe also incoming data is coming, and suppose in fifth subframe, this fifth subframe, the incoming data is stopped. Okay, but still UE will decode this PDCCH. Okay, why? Because this DRX inactivity timer is there. DRX inactivity timer. Okay. Okay, so let's consider another situation. Suppose UE decoded the PDCCH at first subframe here, and incoming data is coming in second, third, fourth, fifth. Also in next subframes, incoming data is still coming. Okay, in that case, what will happen at this point? DRX inactivity timer will be reset. Okay, means still the time U is receiving the data, it will reset this DRX inactivity timer. Why? Because during DRX inactivity timer, UE will decode the PDCCH, and receives data. If again for let's say for four subframe, 7, 8 and 9 subframe, DRX inactivity timer again it will be started. So UE will decode the PDCCS, receive the data, and if still incoming data is coming, then again this situation will continue. Means DRX inactive timer will reset, and during DRX inactive timer, means before expiration of DRX inactive timer, UE will decode the PDCCH and receives the incoming data. Okay, so let's say in our case, at fifth subframe, here DRX inactive timer got expired here. Okay, here at fifth subframe, this DRX inactivity timer got expired. Okay, so after that UE will go back to sleep mode again for next subframes. Why UE is going in sleep mode? Because after this, means at fifth subframe, data reception is stopped and UE is going to in sleep mode for 4th, 7, 8, 9 and 10 subframe. Okay, so after that again your long DRX cycle will be started. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 subframes are here. 3, 4, 5, 6, 9, 10. Okay, so again from here, from this point, long DRX cycle is started, that is for 10 millisecond, and in those 10 millisecond you will decode the PDCCH in first 2 millisecond. Okay, so here again it will decode the PDCCH. Suppose no data is there, so again you will go back to sleep mode. Okay, and if some data is received here, so again your DRX inactive timer is start for next 4 milliseconds, that is in 3rd, 4th, 5th, 6th, 7th. So for this period of time, if data is there, then for next 4 millisecond UE is going to decode the PDCCH. Okay, as we have seen in previous condition. Okay, so this is how this long DRX cycle will work. Okay, so short DRX cycle will cover in next tutorial. Okay, thanks for watching.